We have taken an example that the data from optical instrument was collected for our pieces, and 121 values have been obtained, right? So the first thing that we develop from a large amount of data is the development of frequency distribution. So we have got the frequency distribution. We have class limits defined in Excel. We have XU as the upper limit of the class. We have X value as the class mark, which is the mid value of an interval, and their corresponding frequencies, right? In order to do a comparison, we require the, with the normal distribution, we have to compute the theoretical frequencies of a normal distribution, which is governed by the mean value from the data and standard deviation from the data, right? So we have to compute that one. And you know what's the procedure behind that. So let me take those values from the book, right? So for the time being, what are the values? Let's see. Okay, mean value is not available, is not given. So I have to compute that. Let's take that value from the book. Right? Otherwise, our demonstration will remain incomplete. Okay. Not here. Okay. I think I have came to the same problem. Okay. So the mean value is 3.369 and standard deviation is 0.0629. So that we can readily start our calculation. So mean value 3.369 and standard deviation I pick as 0.0628, I think 629, 0.0629. Okay. So this is these are the mean values and standard deviation values. Now, in order to get the probabilities, first the probabilities, we have to convert X values to Z values. So I define the lower limit for a class, right? And the upper limit for the class. And how to define that one? We take the corresponding X value, X lower limit minus the mean value. Let me pick that value in this fashion. It is available at the location D4 in G column, and at the fourth location, value has been picked out properly, divided by the sigma. Since I want to keep these values fixed in all of my calculation, therefore I have used this special selection procedure with the dollar sign. So G $5. So standard deviation will be picked. So these are the value. You will do that one with the table, right? So I have got the area calculation from -infinity to the lower limit of Z. This has been computed because I want to compute the theoretical frequencies for a particular class, right? So observed frequencies are in column D. Now for ZU, I will do the same thing. I will select a value of XU minus again the mean value X minus mu over sigma, which is G $5. And I will repeat these values. Computation of Z values, and now probability. So I know the probability I have to compute the probability up to the upper limit minus the lower limit. That will give me the probability of interval. So I will say probability and I set it to theoretical one. So instead of using table, since I have the Microsoft Excel sheet, I'm going to use here the function. So normal standard distribution. Yesterday I introduced that. So I have to provide a value. So upper limit value, and I have to set the other parameter as true. Cumulative is required, which is an expression of area evaluated from minus infinity to that particular value. This is the probability. Minus the same thing for lower value, right? So take this value and true. This is the probability of finding the value theoretically in the first class of the distribution data, right? And then we have repeated that procedure, right? It's just like a loop calculation. And now computing the frequency, theoretical frequency. So please notice that these probabilities have been computed by considering the mean value and the standard deviation. So they really represent the normal distribution, but we are not sure about the data. So now for comparison, let's compute the theoretical frequencies, and we call them expected frequency, which means frequency from model, expected frequency from a probability model. So that is simple thing. In that case, you have to multiply the probability with the total number of observations. So let's calculate the total number. Right here, this calculation in this cell equal to summation of all the values of frequency, right? The total number, that is 121, right? So probability of finding the value here, and then the frequencies are this value times the value, the total number of observations, right? So D dollar, it is at location 13, or you can just simply write here 121 for this problem. So the frequency is 0.321. So all values have been computed. So let's check whether this one is equal to the theoretical, the observed frequencies or not. So I write here a summation. So it is 121, right? Now we have to make a comparison, right? So the comparison is basically established by a statistical test, a statistical calculation. It's not just a kind of just by inspection, right? But for the time being, let's stop up to this point. So see the procedure. We have computed the theoretical frequencies from normal distribution. So if the theoretical frequencies and observed frequencies, if there is a reasonable match. Now, some values are exactly equal, some values are not, then what to say, right? So we have to set a criteria whether sometimes like the match is about 80%. Is it acceptable to you or not? So we have to define this criteria. So for the time being, let me show you the results of it. Again, not numerically, but just from the pictorial point of view. So the calculation, these are the two distributions. The expected is shown in red and observed is shown in the blue format, right? So right now, we are not sure about whether we can assume our data belongs to normal distribution or not. But that is the procedure. That is a step that we will add in the coming lectures. How to really say it belongs to a normal distribution or not. That is by writing the chi-squared test, right? So for the time being, we are going to stop at this point for this demonstration.